And we are live with another Vulkan tutorial. Last time we set up physical and logical Vulkan device, which is basically our GPUs. Now we're setting up the Q family indices. That's a quick word. Okay. So Q family indices is um, basically it's gonna be our queues, and that queue is from our queue family. We need to get a queue from our queue family, and yada yada yada. Let's get on with coding, I guess. So we need to go back to our Vulkan device here. What we need to do is get a VK. From our physical device, we need to get our Q family indices. So this would have a Q family. Oh wait. So uint. So the Q graphics family that's gonna be is gonna be an uint 32 underscore t graphic. Well, let's make a new class. Whatever. Class family indices. It's gonna have a uint 32 underscore t graphics family, and I'm gonna keep it as private. This is gonna be like a regular, or we can just have it a struct. Let's have it as structure. It's easier having a struct. So we have a struct, and this is going to be our Q family indices. In it, we're going to create a new function called void set up Q family. Now go back to the source, Vulkan device, and we need like a good separation between our Vulkan device and physical device. So what I'm going to do is separate it with that. Vulkan physical. Vulkan physical device, and this is our Q family. Is abstract, so we don't need to worry about it. So this is gonna have a Q family indices. Q family, and we're gonna have an inline const Q family indices get Q family const return Q family. So we're basically getting our Q family indices after we said should be good enough. Looks like. So when we init, we want to make sure we do this set up Q family and avoid Vulkan physical device set up Q family. Now I'm not gonna have it return. This is just gonna return a Q family indices, so we need to do the logic to get the Q family indices. It's a weird process, but so Q family count, get physical device Q family count. So we need to get a family count. So uint 32 underscore t Q family count. VK get physical device Q family properties. This will take that device. Logical or physical? Physical device, yep. So I wonder if we name P device. We get our physical device and Q family count, along with a norm pointer, and that's it. Now we need the vector of our Q family property. VK Q family properties. Family, and allocate enough space for the family counts. VK get physical device Q family properties and pass it back in. So P device, physical device, and Q family count, and then Q family dot data. And basically this is going to get all the Q family's properties. So there's multiple different families. Let's bring up QUEE families. Looking through the it's somewhere in here. Q creation. There's a Q family get family Q priorities. I guess there's not as many Q families. Well, here's a VEZ interpretation of what Q family is. So we are right here setting up the device on our application. There's a graphics queue, compile queue, transfer queue. Well, we're right here actually, and we need to create this queue here. We completed the physical device and the device. We need to create this queue. So yeah, we're gonna mainly stick with graphics because this is a graphics library. The compute would be your computation. I don't know what transfer queue. Maybe like transfer images between the graphics card and the computer. But anyways, that's what a queue, those types of queue is. And yeah, let's get back onto getting that. So we get our family properties. We need to loop through all of it. Excuse me. And get our different types of cues. So, let me get some. What I would like to do is keep the cue families all together, but oh yeah, graphics family. Okay. Got it. So once we have the graphics, all the families, we can basically loop through this. So for constant auto reference Q, I guess. Yeah, QF for Q family. Q family. We loop through it if QF dot Q flags. We end it with the VK QE graphics bit. We want to set the graphics whatever. So the current queue is the graphics bit. We just want to get the indices. So if the current queue is the graphics queue, then we can set the indices. So queue family dot graphics indice graphics family equals I. What is STD optional? Yeah, let's put this as an STD optional. So what STD optional is does not have a value until it has something assigned to it. And we can use a has value to check if it has a value, which is just okay right now because we're not doing anything that important, I guess. So now we got our graphics indice, it looks like. We can create our logical device. Go back and create that logical device. Which is pretty simple because we already have it created. We just need to pass in the queue create info and queue create info count. So when we create our logical device, vk device queue create info. So let's separate some stuff here. VK device queue create info, queue create info, And this is just going to create our queues for us. So now we want to set the structure type for this queue create info. So vk structure type device queue QUE UE create info, and we need to pass in the graphics family indices. So q create info dot q family index indices graphics family dot value, and this is going to be our physical device. So pd dot get dot graphics family get graphics family dot value. So get, actually it's not graphics family, it's q family info indices dot graphics family dot value. And then the queue count is 1. Info dot count equals 1. And that's basically our queue create info. We can pass it back down here. And since we got our queue create info, we can set the priority. Queue info queue priority queue priority, and this would just be a float, so queue priority of 1 float. So now that should create our device. We also destroy device, and we need to get the queue, because once we create the device, the queue is there, but we need to get the queue from the device. So all we need to do is call vk get device queue. We need to pass in the device, so physical device, and then get from our graphics family our device queue. So physical device dot get queue family indices graphics family dot value. We're going to pass in 0, and then graphics graphics queue. This is going to be our private variable because we need that. So back in device here, we're going to have a vk queue called graphics queue, and then inline cons vk queue get graphics q, constant, and then return graphics q. And that's it. Let's make sure we get the graphics queue. Yep. Let's make it, check it for any errors, and continue on. cd workspace make. So I did misspell structure here. And that should be down here, I think. Yep. And then get Q family indices. Is actually a pointer, I guess. Hold up. Yeah, it's a pointer, so that physical device. Oh wait. Yeah, this PD is not a pointer. We need this physical device. That. And then same thing down here. Physical device. And then same thing back up. No, because that's actually our physical device pointer. We just need to dereference the PD. Dereference it. Create device cannot convert pointer VK device. Oh wait, this is not the. We need that device. Bin debug sandbox. Start the application. We got a GTX device, and when we close it, we still have an error. Let's see what this has not been destroyed. So we have something not being destroyed here. Destroy device. So let's go back to our main here. Core, sandbox, source. Actually, no, we can use the GDB. So GDB bin debug sandbox. We run it, and then our closing, and then use backtrace. So backtrace say VK destroyed device is causing our function to basically segfault. Let's go over here, and so it's the VK destroyed device. I'm wondering if the VK create device is not YouTube log get logger could not create device. Quit yes make. even though I can just use make right in GDB. Run. So it does not look like we are crashing there. VK destroy device still. Okay. Let's look at the process here. So back in our main, we have our Vulkan device, get instance init. Our Vulkan device creates a device. Create device, get physical device. So we're not getting anything from the physical device. Get instance. Let's go over to our Vulkan device here. Take in the instance. And also keep an instance of the physical devices. Should be, oh wait, okay, physical devices, yep. In the init, go back over here, in init, we go through all the physical device. Devices and make them object. So we move through, make them all objects, devices. And then when we start it, we give it a physical device, and then we initialize it. We set up queue families. And get the graphics bit. So, yep. Do we need to destroy a physical device? Let's see here. Destroy device. Here we go. Device features. Physical device candidates. Blah 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 blah. Is device serial. Queue families. Graphics family. Families. Move through it. Okay. Device suitable, blah blah blah. And now we're going to create the queue count. graphics family dot value. Let's look at the graphics family dot value. Cannot create device. Okay. Looking at the failure codes, let's see if it's equals VK success, cannot create device. We're gonna keep it to a result here. If it's equals success, so result equals VK error initialization failed. If the initialization failed, then we get this. So make. Don't see any initialization failed, so exit. Backtrace. Question marks. Yay, that's always fun. Destroy device. Destroy device, but it's not. VK destroy device. Let's actually make this a heap allocated object so we can control when we delete it manually. So delete the window first, Vulkan context last, so delete Vulkan device. We're gonna have to create a pointer and then set it to new YouTube Vulkan device. Make, and since it's a pointer, we need to call the arrow operator. Run from the beginning, and so far so good. Exited normally. That's pretty much okay. So when we destroyed objects on the stack, I guess it's the destroy objects in the orders that they were created. So when we destroyed our context, we actually or when we destroyed the device, the context was already deleted. So we need to destroy the device before the context, if that makes sense. But anyways, that's basically the Q family indexes. Yeah, basically that's the Q family indexes. Next time we are gonna look at the presentation. Oh, this is good. Or the presentation objects, which is going to be our window surface. The next thing is the window surface. After window surface is going to be swap chain, and then image views. So hopefully we all see you all next time.